Okay, cool. Yeah, so for folks who are not familiar with me, my name is Illia. I'm co-founder of Near. Before diving into a crypto rabbit hole, I was actually an AI researcher. I worked on natural language understanding, machine translation, question answering, and I was part of the team who developed Transformer, which is an architecture that is used right now across all of the machine learning, advanced machine learning. Now, in 2017, I left Google because I wanted to apply this technology to what now we call vibe coding. Effectively enable anyone to be able to program, to develop software, to talk to a computer. Now, back then, it didn't work yet. We didn't have the scale, we didn't have the data. And so we were trying to do a lot more data labeling. We actually engaged students around the world to create training data for us. And we ended up having this challenge on how do you actually pay them, right? People in China, people in Eastern Europe, Southeast Asia, they don't have bank accounts, monetary restrictions, et cetera. And that's how we got into blockchain, realized there's a need for something scalable and really usable, and started building Near. Now, AGI is almost here. And the point of this is whoever controls it, whoever provides the access, whoever defines how it's able to be used or not, is in control of everything that it provides. We already see this in sciences, we see this now in kind of technology and day-to-day usage, and this is going to continue expanding more and more in our day-to-day. There's a paradigm shift that's happening as part of this, which is, over past 20 years, we've gotten used to navigating to websites to get something done, using applications on our phone. But it's starting to shift, right? It's starting to move away from, oh, I need an app for this, I need an app for that, to I just have my AI with maybe agents who are actually doing things for me. Now, the interesting thing is the kind of final form of this is where instead of asking for information, the AI is going and actually doing the work for you and executing the actions, right? So this is kind of agents taking actions, which we're all excited for. But what it means is that the user experience is going to change. You're not going to have anymore a bunch of apps on your phone. You're not going to have a browser with websites. You're actually just going to have AI that's going to go do all these things in the back end. And instead, it's going to generate the user experience on the fly for you in this specific moment. And in process, it's actually going to eliminate a lot of middlemen and kind of processing that happens right now. Now, there is a challenge with this, and there's a bunch of challenges with this. One of them is monetization, right? If I'm a developer right now, I want to build a new model. I have two routes. One is I build a new model. I now need to get a bunch of compute and build a whole kind of infrastructure to serve it so I can actually monetize it. Or I open source it and don't make any money. As closed source, now you're taking responsibility for everyone's data because you're serving it, you need infrastructure. One of the challenges we see is that as a model developer, you're afraid of giving your model to other compute providers. That's why all of the compute providers like Akash, like Together, like Fireworks, don't have any closed source models. They only serve open source models because none of these companies willing to give it to them. We also have a ton of challenges. I mean, Greg mentioned a bunch of them, right, around energy consumption, global latency, right? Like why, if you're sitting in Japan, you're using a model that's being served from Tennessee. You obviously have massive data center in Memphis that consumes a ton of energy, even though you can have smaller data centers around the world for energy consumption. You have a ton of challenges with corporate security, just uploading data and not even realizing sometimes they're doing that. And you have a country sovereignty where you're using some model which a company effectively decides if you can use it and how you can use it, and effectively defines how your GDP gonna look like in the future. There's also a lot of safety concerns, right? I mean, the reason why some of the companies don't release their model is because they're afraid that it can be misused. Although at the same time, we have open source models and people are using them in all kinds of different ways. But the other flip side is if you're sitting inside one of these frontier companies, you actually have an access to the unaligned model, unsafe model. So we have actually an interesting misaligned state where if you want to misuse these models, you actually just need to get a job at one of these companies, because that's the best way to get access to an aligned model. So instead of like the current state, what we propose is a user-owned AI. It's really AI that optimizes for user well-being and economic success, not the profit of these individual corporations that are working on these models, right? So it's a different paradigm, different model, different system to allow this. Now, to ensure that, we need a number of things to kind of work together. And kind of the properties we want to deliver is, first of all interactions from your perspective should be confidential and permissionless, right? Like I should be able to access, if I know I can access this model, I want to access it, it shouldn't change tomorrow, and my data should not leak to I don't even know who. We want it to be accessible to everyone, right? It should not be guarded kind of in different ways to different people, right? It shouldn't be that when I go to Korea and like it says I cannot access this model, when I go to Hong Kong, I cannot access that model. You want to ensure the user ownership, right? Again, right now, these models, like the meta optimization is either way maximizing revenue for the company. And so we want to kind of be the flip side of this where we're maximizing ownership. We want to have, know how these models are trained, right? There's this concept of sleeper agents where you effectively can introduce some information into training data of a model in such a way that at a later stage it will activate some malicious behavior, right? This is especially true for coding models where you can effectively turn which library it imports on a specific condition and introduce vulnerability into software. And so we want to know what goes in, we want verification of what goes in, we want to be able to understand the bias that model has. So in general, we want to have this kind of in a new paradigm that right now nothing offers. And so the other problem is that this new paradigm on itself will not gain users, right? We in crypto, been saying, hey, crypto is great, values of self-sovereignty, and maybe, we got like, whatever, maximum couple million of users who actually like truly have their own self-sovereign keys, right? Most people use centralized exchanges to transact. So we need a state-of-the-art model that actually represents this value so people are using it. And so we want to have verifiability of data and model training that goes into this for the process of getting the best model. One of the challenges here is if you have the best model that is effectively open source, everybody else can use it and so and improve on top of it as faster. And so you're always going to be lagging behind. So there's kind of an interesting challenge that if you fully open source, you cannot be state of the art, right? You always will be lagging behind somebody building right away on top of you. We also need continuous research and improvements, right? So we need a process. Like the important part here, like the thing that OpenAI has is less about the specific weights, floating points that they have, but actually the process they have to produce it continuously and improve the model and research that goes into it. And so we introduced this idea at NVIDIA GTC. It's called decentralized confidential machine learning, right? So this is where we have a new primitive that allows to have all interactions with the model to be fully confidential and permissionless, right? There's nobody who can actually stop you from doing that. The results are verifiable. This model was run on your data, and only this model, there's nothing else was executed. We can have data centers across the world who actually serve in this model. We can monetize now models, so I can build a model and make money off it, offering it through this network. I can train model in such a way that everything that goes in is known, but the outcome is effectively encrypted and available only if you monetize it. And it offers a way effectively to provide safety over these models in whatever way the designers desire that applies equally to everyone. Like effectively you saying, hey, this model can be used for everything except bombs, chemical weapons, etc. And this applies the same way for everyone who uses it, not just for external users and creators can do whatever they want. So how does this work? Well, it relies on few key primitives. So first one is trusted execution environments. Its ability to run hardware, specifically Intel CPUs and NVIDIA GPUs, in such a mode that even the owner of the hardware is not able to access what's happening inside. So this gives you both confidentiality and verifiability. It works with GPU, NVIDIA Hopper, and Blackwell. There's other hardware providers that also adding support for it. And you can actually run arbitrary computation, right? You can run agents, you can run, access data, data processing, training, etc., because it runs on Intel TDX, kind of Intel Xeon processors as well. And so on top of this, we kind of build the whole cloud, where you effectively have nodes that can join network, turn on this mode on their compute, and then register that they're able to provide this on-chain. And now you can have models that are encrypted, that only decryptable inside confidential environment, and served to the user, right? So this is how you get, effectively, ability to monetize models, where you can have the model encrypted. So like I just trained something new, I encrypt it, upload it. Now, only inside Secure Enclave it can be used, and you can apply whatever requirements, payments, monetization kind of restrictions that you want on top of it. So there's a lot of pieces that go into it. There's a whole paper that introduces how this works. Now, on top of this, if we want a state-of-the-art model, that's not enough. This is kind of your inference network and compute network. But you still need the whole AI laboratory, right, that actually produces these models, right? You need the whole kind of flywheel process that produces these models continuously. And so if you look up into one of these labs, inside they have a number of teams, right? And each team is effectively like pipelining, getting more data, passing it to pre-training. Pre-training passes new models to like RL, kind of reasoning RL, fine-tuning, and then back to inference. And so you kind of have a continuous flow of this where new data refines, gets model to improve. So on data side, the important part is data acquisition, right? You want both new training data from internet, as well as if users are willing to provide it from the users, where you can actually clean a lot of PII out of it. You as a user know exactly the procedure that's going to be done on top of your data, so if you're willing to have this trade-off. You have kind of data cleaning and improvement, right? Most of data is shit, so you need to kind of remove all of this noise out of it. And you have also synthetic data, right? A lot more of current training is actually moving now to synthetic data generation. So all of this can be done on top of this kind of hardware of decentralized cloud, while effectively ensuring that you know the provenance of the data and what happened and what went into it, right? So you can inspect the bias, you can inspect the kind of what happened, and there was no kind of malicious injections. On pre-training, we want algorithmic improvements, right? We want to continue improving the models, how they trained as well. You want curriculum learning, you want prioritizing batches, etc. And we want to have a decentralized and distributed training, right? So we can actually leverage the compute that's around the world. And so decentralized training itself is an extremely complex problem, right? I think Nus is presenting afterwards a lot about it. But the cool thing is if you run it on this decentralized confidential machine learning cloud, you actually get a lot of really cool properties, right? You don't need to solve for malicious actors trying to poison your model at the training time, while you're solving for the monetization, right? Right now, if you're training the model in a distributed, decentralized way, everybody usually has a model, like everybody who participated in it, right? So you can't actually monetize it. It's effectively open source. And so you don't have this flywheel of money coming back in to train the new model. So you need this monetization where you can produce a model, and then the weights are encrypted, right? The inputs are known. It's open source, but the parameters are encrypted and now can be used and be monetized. And so you can actually raise money and and repay back from this monetization. You also want all the fine-tuning post-training, right? There's a ton of innovation that's happening on the side, and especially if you're tackling specific sub-problems, you take the foundational model and actually start to expand it into different areas. And so one of the ways to approach this is to take kind of what crypto is doing best, which is creating these competitions, right? It's creating effectively a goal that if you hit, if you're continuously hitting, you're getting rewarded, while the overall system getting improvement. And so the approach here is effectively creating a competition for people to create benchmarks that will attract people to create interesting models that will generate more revenue for the whole system. Right? So you have a whole kind of system, a flywheel of new benchmarks, something that is not solvable by AI right now, that can be confidential, right? Nobody has direct access to the data of this benchmark, but they can run their model on it. And so the better models that arrive, they get rewarded for beating the benchmark, while the benchmark itself receives reward proportional to how valuable these models are. Right? So you're creating kind of a two-step game using crypto economics to effectively generate this flywheel of better models and better benchmarks. And this is actually what's happening inside, again, OpenAI, Google, and other labs. Kind of how they continue innovating is like every team has its own benchmark, and they're continuously improving the models and passing it down to the next team. And obviously, you still have a market for inference that as you create these models, now people can use them across the world. They can use them on their own hardware. They can use it through kind of shared resources while still maintaining this confidentiality. So at the end, this is kind of foundation of how we're going to build user-owned AI, right? This is the foundation of kind of what crypto is offering, right? This trustlessness. Even if the participants are going to be actually companies, right? It can be that I'm actually build a closed source model to offer it to people, but you allow everyone to now use it in a fully confidential way and fully private way. So this is it. We're building this as kind of a collective effort. We have a number of companies and teams actually building it together. And if you want to learn more, reach out to me on email and Twitter. Thank you.